So now that we've taken a look at a scatter plot, right, and how we can use that to hopefully make some predictions or estimates about uh, um, values that we're studying, we want to introduce some more terminology. And so we want to describe these relationships, right, what we see in these graphs. And so sometimes we say things are positively associated or negatively associated, right, between so, for example, shoe size, right, is associated with foot length. As a person's foot increases, the shoe size increases. Think about that real quick. Of course, right, bigger feet, bigger shoes, they have a positive correlation, or they're positively associated. And so when two variables are associated, there's a relationship. Then there is a relationship that exists if they're associated, right? Males are associated with shorter hair. Females are associated with longer hair. Okay. Again, doesn't mean it's true in all cases. It's just that we have some association. And to use the word correlation, both variables must be quantitative, so you can describe that relationships numerically. Okay. So we say it in association, but when we start talking specifically about these quantitative variables, we use the word correlation. And so again, I just want to make sure you're mindful of that. And so here's another example of a graph. This is locations of cities in the world. Their latitude, right? You have longitude and latitude is kind of their location on the globe. If you looked at a globe, how locations are mapped out on our Earth. The latitude seems to have an effect on your average temperature in January. So somewhere, if you're located in the latitudes of 40s, you have decreased temperatures, latitudes of 30s. So you can see that association, right, or correlation. What direction are the points going? So we speak of an association in general. There's an association. When we start talking about quantitative numbers, specifically quantitative variables, we switch over to the word correlation. And so you can see as these values increase, I see a decrease here. And so you end up, sorry about that, there you go. Increase here, decrease in temperature. And so if you wanted to represent a point like this point, what does this point mean right here? This is a city that has a latitude of 38 and an average temperature of 48 degrees, right? Remember, latitude is that location on our globe, how we map out things. We use other words. There's other terminologies we use because what we're studying in this class, we start with what we want to study are these linear relationships when the data kind of show a pattern of a line, which you see here. And so we have other words we use, strong, moderately, like the strength. The more the points are lined up together, right? So we describe our association as it's a strong association, moderate, weak, moderate to weak, right? So you can see as the points line up, positive, linear. So take a look at some of the words we're looking at here. Notice that there's no association when the points are kind of just all randomly scattered, right? There's a random scattered aspect to it, right? And so that's when you see this randomness here on these here. You see here it's kind of scattered, no association, just the points are kind of scattered all over the place. Versus here, there's no linear, but I see a non-linear curved relationship, right? When we hear that word non-linear, it's curved in some way. Here you can see it's slightly curved in a pattern. You see the curved here. Versus here. And then there's debate sometimes, is it curved or linear? And that's what's happening when we interpret things. So if you mindful of the coronavirus situation, you heard the term flattening the curve. It's because our cases and deaths were increasing in a curved way. And what they wanted to do is, what could we do to try to flatten it so that they weren't increasing so much? That's what it was connected to this type of work here. And then formally, which we'll continue on the next section is we want to not just describe it, but again, this is statistics. So we want to measure. How do we measure the strength of a correlation, right, between two quantitative variables? There's a complex formula here to calculate what we call an R value. And R value is called the correlation coefficient. Again, you want to make sure start getting used to using that word, because this becomes an important word when studying the relationship between two quantitative variables. We look at its correlation coefficient, right? We have this quantitative relationship, and this R value tells us how strong, right, our relationship is, our association is. And so there's certain rules we'll talk about here. You can read these and get those down. But we'll see how, as we go on, how this affects us when we do our interpretation. And so we don't do it by hand. We use StatCrunch, or we use our calculators to do that. Okay.